Okay, so this lesson is going to kind of build off the last lesson, and it's going to kind of help you to build some of those skills and not only prepare for Algebra 1, but kind of review some things you should have learned in 8th grade. So it says solve for y when x equals 10. So what that means is whenever x is equal to 10 here, for this equation, x is equal to 10 here. So in this case, what we're trying to do is solve for y. So that's our goal. So what's nice is starting out, y is by itself, so I don't have to solve for it. So all I have to do is plug that in and start solving. So I've got y equals 10 over 2 plus 4. And something that you should remember is order of operations. So I just saw this the other day. There's this thing called GEMDAS. G stands for grouping. E stands for exponents. M stands for multiplication. D stands for division. A stands for addition. And then S stands for subtraction. So this is actually the order that you evaluate expressions in or equations in if you've got one variable alone. But there's a little bit of an extra step. Multiplying or dividing, actually, it depends on which one comes first when you read from left to right. So if I read from left to right here, I've only got division. If multiplication came first, I'd have to do it. If division comes first, you have to do it whenever you're reading from left to right. Same with addition and subtraction. And I'll see if I can find an example. I know that's a little messy. It's hard to write on any page. I like OneNote a little better, so I'm going to try and export some of these to OneNote. But multiplication or division, addition or subtraction takes precedence. So what we see first is division. So 10 divided by 2 is going to be 5. So I've got y equals 5 plus 4. And then 5 plus 4 is 9, and that's the addition step. So this was evaluated division. And then evaluated addition. So what we have here is a coordinate pair. We plugged in 10. So when x equals 10 on this line, we get that y equals 9. So that's important to note. So you know a coordinate on that line. And then it says solve for x when y equals 10. So what we're going to do is instead of plugging x equal to 10, we're going to substitute 10 in for y. And I'm going to show you how to do that. And in this case, we're going to solve an equation and then evaluate our solution. So we've got 10 equals x over 2 plus 4. So what I'm going to do is solve for x. So when I add 4 here, right, when I see this addition of 4, I'm trying to solve for x. So what I'm going to do first is subtract 4 from both sides of this equation. So 10 minus 4 is equal to 6. And what that does is it gets rid of that constant term, that plus 4. So I'm left with x over 2. So now what I have to do is I have to get rid of this division of 2, right? X is being divided by 2, so what's the opposite of division? Well, it's going to be multiplication. So in order to undo a division of 2, I'm going to multiply both sides by that same number. So I'm going to multiply both sides by 2. So I get x equals 12, and I'm done. So the next thing it says to complete the table using the following equation. B equals a plus 4. And then they give us this table that's partially done, right? So what we want to do is we want to plug in the values that we see for A and plug in the values that we see for B and solve for the other value in that case. So this is called a table. So I want to fill this table out. So first they give me A is -3. So I'm going to plug that in and see what I get. So over here, B is equal to -3 plus 4 over 2. Well, whenever you've got a fraction or an expression that has both terms being divided and you're plugging a number in, I'm just going to go ahead and evaluate the numerator. So I know we said division, and you can do it that way, but dividing -3 by 2 and 4 by 2 is going to be a little dicey. So what we're going to do is this numerator actually acts like a grouping. So we're going to group those two things together and perform the operation that we see. So -3 plus 4 is 1 divided by 2. So I've got 1/2. And then they give us that a is 0. So I've got b is equal to 0 plus 4 over 2. And I do the same thing here. I'm just going to evaluate the top. So 0 plus 4 is 4. 4 divided by 2 is 2. So when I plug in 0, I get back 2. Let's do a few more. And now they're wanting us to kind of rearrange the formula and solve. What I've got here is -7 for b. So instead of plugging it in for a, now I'm going to plug it in for b and leave a to be the unknown. So I want to know what a is when b is -7. So I'm going to do that. So I've got -7 equals a plus 4 over 2. So I want to get rid of that 2. A plus 4 is being divided by 2. So I have to think to myself, what's the opposite of division? Well, that's going to be multiplication. So I'm going to multiply both sides by 2. The 2's will cancel out, or they'll divide out to be 1. Okay, so 2 divided by 2 is 1. 2 times -7 is -14. So I've got a plus 4 equals -14. So now I want to solve this completely out, and I get, I've got an addition of 4, so I can subtract that to the other side. So I get a is equal to -18. And since a is alone, I'm finished with that one. So there's nothing more to do there. So now I want to know what a is when b is 10. So I'm going to do a similar step here. So I've got 10 equals a plus 4 over 2. So what I'm going to do is get rid of 2 down here. So 2 is being divided. So I'm going to multiply both sides by 2. And I get a plus 4 is equal to 20, and then a equals 16, right? Because a plus 4 equals 20, right? Whenever you have an addition here, you want to subtract both sides. So I skipped that step, I'm sorry. So 4 minus 4 is 0, so I'm left with a, and then 20 minus 4 is 16. So I get a is 16 there. So then I've got some nice little word problems down here. And it says the amount of money. So I'm going to kind of circle that one. Let me erase it. The amount of money in Mr. Bean's wallet is $50. Take away $5 for each kid that asks for lunch money. Okay? So I'm going to define my variables. The first thing I don't know is the amount of money, but I can let a variable represent the amount of money. And then it says, is $50 take away $5 for each kid? So the second variable I have here is kid, the number of kids. So M equals the number, or the amount of money, sorry, the amount of money in the wallet, and then K equals the number of kids. And so what we want to do is set up an equation. And so we have, it's talking about money, so M, and it says is. Anytime you see the word is, that means equal sign, okay? So is defines an equation, so that's the equal sign. So M is, or equals, $50, so 50 and it says take away. So take away means subtraction. So minus $5 for each kid. So it says, so that's 5 times the number of kids. And that's how it goes. And it says, how much money does Mr. Bean have if he gave money to all 9 of his children? So we want to know how much is left in his wallet after he gives lunch money to 9 kids. So 9 of his children, 9 children means 9 kids. So K equals 9. So if K equals 9, all I have to do is plug that in and evaluate it. So let's do that. So I've got M equals 50 minus 5 times 9. So that's 50 minus 45, which is 5. So that means he's got $5. And it's important to understand what you're doing whenever you're plugging these equations in. Don't just plug and chug and then get the answer. Understand what the answer means. So how much money does Mr. Bean have if he gave money to all 9 of his children? Well, Mr. Bean has $5 left if he gives money to all 9 of his children. And that's pretty good. He's still got some money left over after feeding 9 kids. That's pretty good. How many children did Mr. Bean give money to if he has $30 in his wallet? So right here, they're giving us an unknown. They tell us the amount of money in his wallet. So money in his wallet, what variable is that? Well, that's going to be M. M equals 30. Okay? And that's $30. So we want to know the number of kids. So I'm going to use this equation that we created up here, right there. I'm going to use this equation. So I've got 30, instead of M, I'm putting 30 in its place, because M is equal to 30 in this case, is equal to 50 minus 5K. So what I want to do is solve for K, but I want to get rid of this coefficient, and I want to get rid of this 50. So there's a few ways we can do that. Notice that the 5, right, I've got a negative symbol in front of it. So I've got essentially this equation. I can rewrite this as negative 5K plus 50 equals 30. So I want to solve that equation. Well, what's happening with 50? It's being added, subtracted, multiplied, or divided. That's the question. And this operation here means addition. So I want to get rid of the addition. So the opposite of addition is subtraction. So I'm going to subtract 50 from both sides of that equation. And I get negative 5K equals negative 20. And then I want to get rid of this negative 5, right? Negative 5 is being multiplied by K. So what is the opposite of multiplication? Well, it's going to be division. So I'm not only going to divide the 5, but I'm going to divide the negative as well. So I've got negative 5 divided by negative 5. The negatives will change the quantity to a positive. A negative divided by a negative is a positive. 5 divided by 5 is 1. So this is 1K. So I'm left with 1K, or just K. You don't have to write the 1 if you don't want to. I tend not to. So K is equal to negative 20 divided by negative 5. Well, we just said that a negative divided by a negative is a positive. So negative divided by negative is going to be positive, and then 20 divided by 5 is going to be 4. So how many children did Mr. Bean give money to? Well, sorry. Mr. Bean gave four kids money. And you could even take it a step further and say if he has $30 in his wallet. And we found that out, so that's pretty good. Let's do another example. It says the student council needs to raise $400. So we know something. That's a known. So they told a talent show, so they hold a talent show and sell tickets. Okay, so we're selling tickets. And we've got two types of tickets. We've got student tickets, so I'm going to let that be S, and then adult tickets. I'm going to let that be A. So those are our two unknowns. And it even tells us that each student ticket costs $2 and each adult ticket costs $5. And we want to know the amount. So S equals number of student tickets and A equals the number of adult tickets. And we want to know the equation. So we know that the total amount is going to be 400. So we know that the number of tickets has to equal 400. And that comes from this part of the sentence. The rest of it, they kind of tell us, right, each student ticket, S, costs $2. So that's 2S. And then I've got each adult ticket costs $5. So 2S plus 5A. So that is our equation. And now we can start to solve some of this out. And it says, how many adult tickets do you need to sell if you sell 200 student tickets? So what they're telling us here is that S is equal to 200. The number of student tickets is 200. So what we can do is plug 200 into this equation, or substitute it in for S, and then solve the equation out. So we've got 2 times 200 plus 5A equals 400. So 2 times 200 is 400. So I'm going to just rewrite this equation. So 400 plus 5A equals 400. Well, what's happening between 5A and 400? Well, they're being added. But I don't want to subtract 5A to the other side because they aren't like terms. In order to be like terms, your constants, I mean whatever term you have, like this 400 is a term, you would have to have an A with it. These 400s would have to have that variable with it to be like terms. So there's nothing to combine. What I want to do is get this variable alone. So I've got this constant term over here, 400, that's being added to 5A. So I'm going to rewrite this equation to make it a little clearer. It's 5A plus 400 equals 400. All I did was swap those two. I just swapped 400 and 5A in this part. So I didn't really change the equation. I just switched the order of these two. So you could see that 400 is also being added. So if 400 is being added, the opposite of addition is subtraction. So I'm going to subtract both sides by 400. And I get 5A equals 400 minus 400 is 0. And I have to think to myself, there's two ways to solve this equation. I can think of it like a question. So A is an unknown, so what times 5 equals 0? Well, anything times a number that equals, whenever anything times a number equals 0, that means the something has to be 0. So 5 times what equals 0? That means A is equal to 0. I can think of it that way. Or I can think of this as multiplication. And that's what it is. So 5 times A is equal to 0. Well, what's the opposite of multiplication? That's going to be division. So I can come over here, kind of show two different ways to solve this. 5A equals 0. So I'm going to divide both sides by 5. And you have to be careful here. 0 divided by 5 is something. But whenever you divide something by 0, not the case. Okay? 0 divided by 5 is going to be 0. If you try and take 0 cookies and split them among 5 friends, they're still going to have 0 cookies. So 5 divided by 5 is 1. So I'm left with 1A, so A equals 0. And that kind of makes sense. Because if we're selling student tickets for $2 each, and I'm selling 200 student tickets, well, 200 times 2 is going to be 400. So I've already met the 400. I don't need to sell any more adult tickets. I can if I want to make more than 400, but I don't need to sell any more. Probably not going to be the case down here for part C. So this is just doing it backwards. And it says, how many student tickets do you need to sell if you sell 50 adult tickets? Well, all we have to do is take that same equation, and instead of plugging something in for S, now we're going to plug something in for A, because they give us the number of adult tickets here. So A equals 50. So I've got 2S plus 5A equals 400. But A, right, instead of putting that letter there, that variable, I'm going to put in 50. So 5 times 50 is going to be 200. So I'm going to do that first. So 2S plus 5 times 50 is 250 equals 400. So then I'm going to subtract both sides by 250. So 400 minus 250, and then 250 minus 250, that's going to be 0. So I'm left with 2S equals 400 minus 250, which is actually 150. So I need to know the number of student tickets, and I know I'm selling them for $2 each. So 2 times S is what I've got going on over here in this part of the equation. So how do I undo multiplication? Well, that's going to be division. So undoing multiplication, I'm going to divide both sides by 2. So 2 divided by 2 is 1S, so I'm left with S. And then 150 divided by 2 is 75. And that's the number. And so don't forget, whenever they're asking these questions, they kind of want an explanation. They don't want you to just solve the equation, they want an explanation. So how many adult tickets do you need to sell if you sell 200 student tickets? Well, I need to sell 0 adult tickets, because we've already got to 400. And then down here, well, if we're only selling 50 adult tickets, we still need to make that $400 mark. So I need to sell 75 student tickets. So the algebra showed us that, and it's a given context, and it's probably something that would make sense in a high school situation. So here's your example. Both of these are going to be your example. So I encourage you to pause the video and try it out on your own, and then I'm going to walk you through it. Okay, so assuming you've had a go at it, I'm just going to go ahead and plug these in. So I've got 2 values of G here. So I want to kind of split this up. So the first thing I'm going to plug in for G is 10. So I've got H equals 2 times 10 minus 7. So that's going to be 20 minus 7, which is 13. And I'm done. So that gives me H is 13 when G is 10. So then I'm going to go ahead and take the same equation and plug in -7 for G and find out what H is. So H is equal to 2 times -7 minus 7. Well, 2 times -7 is -14 minus 7. So -14 minus 7 is going to be -21. So I've got -21 there. So those two are done. So now I need to fill in this table here, but I'm finding G now. So instead of plugging in the value of G and finding H, now I'm going to plug in H and find G. So I've got 7 for H equals 2 times G minus 7. So what I want to do is I want to solve for G. I want to get G alone. So I'm going to get rid of this subtraction. Well, what's the opposite of subtraction? Well, it's going to be addition. So I'm going to add both sides. Hey, that works. All right, -7 plus 7 is 0. So 7 plus 7 is 14. So I've got 2G equals 14. All right, so if 2G equals 14, Well, I want to get rid of this 2, right? I want to get g by itself, and 2 is being multiplied by g. Well, what's the opposite of multiplication? Well, it's going to be division. So I'm going to multiply, I'm going to divide both sides by 2. And those 2's, right, are going to divide out to 1. So I'm left with g. And then 14 divided by 2 is going to be 7. So g equals 7. So when h equals 7, g is going to equal 7. And that just happened to be a happy little mistake. Or not mistake, but a happy little coincidence. It's not always going to be the same value, right? If I plug in 10, I'm not going to get back 13, but just in this case, if I plug in 7, I'm going to get back 7. So I've got one more to do. I've got to plug in 12 for h. I'm left with 2g minus 7, and I'm trying to solve for g. So if I do this, right, 7 is being subtracted, so what's the opposite of subtraction? It's going to be addition. So I'm going to add 7 to both sides of that equation. So I get 2g equals 19. So if I divide both sides by 2, I get g is equal to 19 over 2. And I'm done with that. So then I've got this little word problem to solve. It says Mr. Kelly has to grade some algebra tests and some geometry tests. He has a total of 34 tests. What's the equation to find your variables? Well, I don't know the number of algebra tests. So I'm going to let A equal the number of algebra tests. And I also don't know the number of geometry tests. So I'm going to let G represent the number of geometry tests. So I also have that we have 34 total tests, or Mr. Kelly has 34 total tests. So that's going to be A plus G equals 34. So the number of algebra tests plus the number of geometry tests are going to equal 34. And it says, how many geometry tests does he have to grade if he has 14 algebra tests? Well, what they're telling us here is that A equals 14. And if A equals 14 here, I can plug it in here for this equation. Just substitute it in. So I've got 14 plus G equals 34. Well, 14 is being added to G, so the opposite of addition is subtraction. So I'm going to subtract 14 from both sides of this equation, and I get G equals 20. So how many geometry tests does Mr. Kelly have? Mr. Kelly has 20 geometry tests to grade. And that's it. So here's some of your practice problems. And like normal, I'll do the first one here. It says find y when x equals -5, given that y is equal to -2x plus 7. Well, y is equal to -2 times -5 plus 7. -2 times -5 is going to be 10 plus 7. Negative times a negative is a positive, and I've got 10 plus 7 here, so 17. And that's all I got. So I hope that helps, and do not be afraid to reach out to me if you are struggling with some of this. Catching this stuff early and helping you out is going to be crucial, okay? Because there's a lot to get done this year. I'm going to do my best to help you out as much as I can, but I can't help if you don't ask for help. So take it easy.